Welcome to the second of 4 modules containing technical information related to the South and Southeast Asia Air Improvements in the Region, or SSEA-AIR program. This module provides more detail on the sections of an air quality action plan that characterize the airshed, or portion of an airshed, covered by your action plan, and includes guidance that will assist you to develop the specific action or actions that will result in measurable decreases in air pollution. Battelle, under a cooperative agreement with US EPA and the US EPA's technical team, prepared this module's contents. This module has several objectives. First, we will review important topics presented in Module 1, including the purpose of the SSEA-AIR program and of an air quality action plan. We will then focus on the first 3 sections of the plan template, which include the goals and objectives of your plan, a description of the area where air pollution is a concern, that being the airshed or portion of the airshed, the pollutant or pollutants of concern, a description of current air quality and emissions sources, and a description of the action or actions to be implemented. We provide examples of each of these sections. We recommend that you have a copy of the Air Quality Action Plan template as well as a copy of the Example Air Quality Action Plan that we prepared to accompany this module. U.S. Western State Action Plan to Mitigate Wood Smoke. These documents were distributed to the SSEA-AIR partners and will be available soon at http://www.ssea-air.org. Although based on real action plans from experience at several locations in the United States, the location, agency names, and other aspects of this example are fictional. As a refresher from Module 1, the overall purpose of the SSEA-AIR program can be broken down into 3 main objectives. The first is to build technical capacity in participating South and Southeast Asian countries, municipalities, and cities to enhance their air quality management, or AQM programs, and their ability to perform technical assessments of their current air quality problems. The second objective is to provide a forum for developing and showcasing successful actions taken to reduce air pollution, and for exchanging technical information to help countries implement actions, such as control measures. For example, participants can learn from Taiwan's success over the past decade toward improving air quality, as shown in the figure on this slide. In turn, we hope that participants will be able to use what they have learned to take actions to reduce emissions and improve air quality in their countries and municipalities, and, in the future, will be able to share their successes. The third objective is to produce air quality action plans that include 1 or more new actions, such as control measures, leading to quantifiable reductions in pollution emissions. The first 2 objectives, technical capacity building and providing a forum for exchanging technical information, are the foundation for this third objective of the SSEA-AIR program. The SSEA-AIR program recommends that countries target fine particulate matter, or PM2.5, for pollution reduction because this pollutant has been the focus of much research and is commonly used as an indicator of exposure to air pollution, although reducing the emissions of other pollutants such as NOx, ozone, SO2, and VOCs may also be pursued. On this slide, we re-emphasize the purpose of developing an air quality action plan. Recall from Module 1 that an air quality action plan provides a framework and specific steps for taking action to improve air quality. An action plan uses local data and scientific analyses and includes 1 or more substantive actions that will lead to quantifiable reductions in pollutant emissions or in measured pollutant concentrations. The components of an action plan are shown on this slide. A key point is that an action must be a new action rather than one that is already underway or has been completed. However, a new action can be an action that has been completed elsewhere that you now wish to duplicate in another airshed. The first step in developing an action plan is to describe the geographical area to be addressed. Following this, the action plan identifies the pollutants of concern, remembering that the focus of the SSEA-AIR program is on PM 2.5. When and how often elevated levels of pollution occur and how high these elevated concentrations are, the sources of air pollution, the proposed action or actions, that is, control measures, and a method for evaluating their effectiveness. Also, the plan should discuss whether any components of your air quality management or AQM program for your country, province, or city needs to be improved. For example, does your emissions inventory need to be updated? Do you need to deploy additional air monitors? Are these improvements needed before or as part of your action plan? In the remainder of this module, we will discuss how to develop your action plan's goals and objectives and the first 3 sections of your action plan, which include characterizing your airshed or portion of an airshed, describing the area's current air quality and emissions, and the action or actions to be implemented. Along the way, we provide examples of information from SSEA-AIR partners and from the Model Action Plan on mitigation of wood smoke. As described in the action plan template, your action plan must be based on local data and scientific analyses and include one or more on-the-ground actions or control measures that lead to quantifiable reductions in pollutant emissions or in monitored concentrations. Again, each action in your plan must be a new action rather than one that is already underway or has been completed. The goal of your action plan may at first be preliminary, but it can be refined as more information becomes available. Whether you have a preliminary or well-defined goal, the guidelines for setting that goal should be SMART. That is, the goal should be specific, measurable, attainable, relevant, and time-bound. If needed, you can repeat this goal-setting process several times as you gather more information. This slide shows examples of the type of metrics you can use to measure the effectiveness of your action plan. Metrics may include the expected decrease in the amount of emissions over time, the number of polluting units changed out for cleaner ones, healthcare costs avoided, environmental cleanup costs avoided, or a combination of metrics. These metrics will be used to measure the extent to which your action plan objective is attained. As shown on this slide, examples of action plan objectives include: by 2022, develop new and improve enforcement of existing air quality regulations to reduce industrial fugitive particulate matter, or PM, emissions by 50%. By 2024, reduce fine particulate, or PM 2.5, emissions from open burning of agricultural waste by 25%. While the outcome of an action plan should be a quantifiable reduction in emissions, your plan may include interim steps, such as improving emissions inventories, air monitoring, or quality control. An objective for an interim step might be: by 2021, update our emissions inventory to include current levels of PM 2.5 and black carbon emitted from mobile diesel sources. These example objectives are specific, measurable, and time-bound. However, you need to ensure that your action plan objectives are attainable and are also relevant to stakeholders, whose buy-in is often critical to the success of an action plan. Stakeholders will likely be interested in actions that improve human health, protect or restore the natural environment, or support economic development, or a combination of these outcomes. An example of an action plan objective is given on the next slide. To accompany this module, we have prepared an example action plan entitled U.S. Western State Action Plan to Mitigate Wood Smoke. The objective in the example plan is to reduce the concentration of fine particulate matter in an area called Mountain Valley during wintertime temperature inversions, so that by 2023, the area attains the U.S. 24-hour or daily National Ambient Air Quality Standard for PM 2.5, which is 35 micrograms per cubic meter. As previously mentioned, if you are having trouble defining your action plan goals, start with a preliminary goal and refine it as you collect information. For instance, perhaps you know that reducing PM 2.5 emissions from open burning is important to stakeholders in your airshed that is the focus of your action plan. Questions you might ask are, what specific types of burning take place? Which types are causing the most severe air quality problems? Are these problems seasonal or year-round? Then, consider which types of emissions have the greatest chance of being successfully reduced, either by establishing controls on the timing and conditions when burning is permitted, or by introducing alternatives to burning. Discuss options with stakeholders and be sure that they agree with your proposed actions. You also may wish to develop a stretch goal, or a goal that is a challenge to attain yet would have a greater positive impact on human health and the environment. Finally, we encourage you to consult with partner countries in the SSEA-AIR program, with EPA and/or EPA Taiwan. Developing your action plan starts with characterizing the airshed, which can be defined as a geographic area within which air pollution is freely and routinely transported and that is influenced by shared sources of pollutants, weather, and terrain. Under Airshed characterization of your action plan, Section 1 of the template, introduce and describe the airshed, its geography, topography, population, and location of major roads and industrial sources. A map is useful for this purpose. Include a summary of the air quality issue and pollutant or pollutants of concern, such as PM 2.5, ozone, sulfur oxides, nitrogen oxides, and/or volatile organic compounds. As mentioned previously, we recommend focusing on PM 2.5 as it is a good overall indicator of air pollution. Also, include details of annual and seasonal meteorology and describe the climate and wind patterns. If available, include pollution back trajectories to better understand where pollution that affects your focus area is being generated. Examples of characterizing an airshed are given on the next slides. This slide shows the type of graphics that can be used to characterize an airshed. On the left is a map of Kuching, Malaysia. The center graphic is a wind rose showing that the prevailing winds in Kuching are from the west, southwest, south, and southeast. The right graphic shows pollution back trajectories for Kuching, generated using the high-split model. Wind roses and back trajectories are easy to generate and are particularly helpful for identifying locations where pollution is being generated and how emissions from these sources are transported in the airshed. EPA can assist you in producing wind roses or models of back trajectories. Here is another example of airshed characterization. This information was presented at the workshop in Taipei in the summer of 2018. Ulaanbaatar has a population of 1.5 million and is the capital of Mongolia. It is located in the Tool River Valley, bordering the Bagd Khan Ul National Park. It has an elevation of 4,429 feet, or 1,350 meters, and a monsoon-influenced, cold, semi-arid climate. Its average annual temperature is 71 degrees Fahrenheit, or 22 degrees Celsius, with winds typically out of the southeast at 9 miles per hour, or 14 kilometers per hour, and receives an annual average amount of precipitation of 10.5 inches, or 26.7 centimeters. Air pollution is a serious problem, especially in the winter, when smoke often obscures vision and PM 2.5 often exceeds levels recommended by the World Health Organization, or WHO. The location of the city in a valley between mountains makes it vulnerable to temperature inversions and stagnant air conditions, which cause elevated concentrations of PM 2.5. The main sources of this particle pollution are coal stoves used for heating and cooking and local coal-fired power plants. The example air quality action plan that accompanies this module provides another example of how to characterize an airshed. Mountain Valley, which has a population of 50,000 people, is situated in a 50-mile or 80-kilometer wide valley that lies between the coastal mountains and the snowy mountains. Like in the previous example in Mongolia, PM 2.5 concentrations are elevated in the wintertime due to air inversions, which occur when cold air containing smoke is trapped in the valley below a layer of warm air, and which persist when winds are calm. In Mountain Valley, the source of fine particulates is mainly from wood burning by small businesses and residents for heating homes. To characterize this airshed, the model action plan shows the location and population density of the valley. It also includes graphs showing the correlation between wintertime PM 2.5 levels and wind speeds, with higher PM 2.5 levels when wind speeds are lower. Your action plan should be for an area that has a well-defined air pollution problem and where you have good relationships with potential stakeholders. If you are having difficulty defining your airshed, you can work with SSEA-AIR program participants and partners who are developing action plans for areas with similar air pollution issues. Technical help is also available from EPA and EPA Taiwan. In Section 2 of your action plan, you will describe the current air quality in the airshed and the sources of pollutant emissions. You should include a list of pollution sources by source type, including stationary sources, mobile sources, and transboundary sources. That is, sources outside of your airshed that contribute to pollution in your airshed. You can obtain information on the various pollution sources from an emissions inventory. If that is unavailable, emissions information can be obtained by reviewing operating permits for industrial sources and by requesting information from equipment manufacturers and regulatory agencies. If available, these data should be used to help rank sources in terms of their actual emissions or potential to emit. If an emissions inventory does not exist, you may consider developing one as a preliminary step in your action plan. As well as sources within an airshed, sources from outside the airshed or transboundary sources should be identified. Although these sources may complicate attainment of the goals and objectives of your action plan, it may be possible to coordinate control actions with contributing regions beyond your target airshed. To describe the current air quality in your action plan airshed, you should provide information on relevant ongoing air measurements, including the location and type of air monitors, their dates of operation, and the pollutants being measured. This information will also help identify any potential gaps in monitoring information. Also provide information on existing air quality control laws and regulations, and discuss whether the air quality in your airshed is in attainment with applicable standards, such as the World Health Organization's air quality guidelines. This slide shows data collected to characterize the air quality in Ulaanbaatar and the Tool River Valley of Mongolia. On the left are measurements of PM 2.5 and PM 10 concentrations from several air monitoring stations by month, where 1 is January, 2 is February, etc., over a period of several years, along with the applicable air quality standard. Here you can see that the particulate concentrations are highest during the winter months. The right-hand graphic shows the approximate proportion of particle pollution from different sources, including residential home heating, an aging vehicle fleet, coal-burning electrical utilities, and area sources such as waste burning, resuspension of soil dust, and construction activities. Understanding where emissions are coming from and when pollution is greatest will help you develop your action so it will be most effective. In our hypothetical mountain valley in the western United States, the Mountain Valley Clean Air Agency collected data to characterize particle pollution in its airshed. The graphs show that all parts of the U.S. western state, including Mountain Valley, are in attainment with the annual PM 2.5 standard of 12 micrograms per cubic meter. However, Mountain Valley is out of attainment with the 24-hour PM2.5 standard of 35 micrograms per cubic meter. PM2.5 levels are highest in winter and can reach several hundred micrograms per cubic meter, consistent with the conclusion that wood combustion during air inversions is causing the pollution problem. Here is the PM2.5 emissions inventory for Mountain Valley and a pie chart showing the distribution of sources of PM2.5 in the winter. These show that fireplaces, wood stoves, and outdoor open burning are responsible for nearly 2/3 of the fine particle pollution in Mountain Valley in the winter. Thus, the action plan targets these sources for emissions reductions. If you are having trouble describing the current air quality and pollution sources in your selected airshed, you can use the process of developing an action plan to identify critical missing information or data. In doing so, you may determine that you need to improve your air quality management program before implementing an action plan. For example, you may need to develop protocols for ensuring the accuracy of air monitoring data or for analyzing and interpreting these data. In addition, as part of the SSEA-AIR program, you can exchange technical information with other SSEA-AIR partners who are dealing with similar air quality issues. You can also ask EPA or EPA Taiwan to help identify appropriate data for characterizing air quality and pollution sources. In addition, there are online open source statistical data analyses and data visualization tools available. You may also consider teaming up with a university or research institute to work on addressing technical issues. Characterizing the area that is the focus of your action plan defines the extent of an air pollution problem and what's driving it. This provides the basis for defining appropriate actions that will lead to measurable decreases in air pollution. Selection of a particular action will likely need to be supported by technical analyses, such as a cost-benefit analysis and a review of alternative control measures. It will also need the support of local authorities and the principal stakeholders. We will give more information on stakeholder involvement in a future module and at the upcoming workshop in Taiwan. Discuss whether your proposed action is voluntary or mandatory. Voluntary actions may be easier to implement, and incentives can be effective. However, success in reducing emissions may be difficult to achieve if control measures are optional. Mandatory requirements may be more successful, but may require additional resources for enforcement and for updating air quality regulations. Also note whether your proposed action is based on existing technology, such as switching fuel sources in industrial boilers, or on an emerging technology, such as installing a new type of pollution scrubber. While emerging technologies hold promise, they may come with a greater risk to project success. We will provide more details on risk management in an upcoming module and at the upcoming workshop in Taiwan. Finally, you will need to develop one or more metrics for measuring the success of your action plan. For example, an estimate of tons per year of emission reductions or a measure of public health benefits, such as hospitalization costs avoided. As an illustration of selection of actions to be implemented, we will use the example from Mongolia. Coal heaters and 3 coal-fired power plants were determined to be the primary source of fine particle pollution in the Ulaanbaatar area. Thus, the proposed actions focus on fuel replacement and on pollution controls to reduce emissions. The Environmental Ministry in Ulaanbaatar will develop new policies, sponsor change-out and retrofit programs for coal stoves, increase community outreach to build support for new regulations, and improve their air monitoring and data analysis capabilities. In the Mountain Valley example, selected actions include a wood heater change-out program and development of a burn ban regulation that will restrict the use of non-certified wood heaters in all outdoor burning during air inversions. Specifically, to reduce emissions from wood heaters, the State Department of Environmental Protection will provide $1 million in rebates to residents as an incentive to replace their older wood heaters with EPA-certified stoves or with other cleaner heating appliances, such as gas heaters. To track the progress of implementing the action plan, the Mountain Valley Clean Air Agency will keep a running count of the number of wood heaters replaced and of the PM 2.5 emissions reduced. In addition, the City of Mountain Valley will hire inspectors to ensure compliance with the burn bans for both open burning and residential wood heating with non-certified appliances. The inspectors will keep a compliance record, which will be used to measure success of the burn ban regulation. Mountain Valley will also continue to monitor hourly and daily PM 2.5 concentrations year-round to track trends in particle pollution over time. If you're having trouble identifying an action, you should review the main sources of PM 2.5 pollution in the Airshed and make sure that these sources are ranked accurately. Select an action that both addresses a major source of the air quality problem and that has a high probability of success. This action should also be one for which there is local support. You can work with your SSEA-AIR partners who have similar air quality issues and select an action that they have found to be successful. EPA and EPA Taiwan are also available to provide technical assistance. You have now completed Module 2 and should have enough information to get you started on developing the first sections of your action plan, including developing your goals and objectives, characterizing the airshed, and identifying one or more actions to be implemented. Our team's technical experts are available to answer your questions and to support you during the development of your action plan. Here is our contact information. You have now completed Module 2. Thank you for your attention, and we look forward to helping you develop an air quality action plan that has an excellent chance of success.